4. A block of mass m rests on a rough horizontal plane having a coefficient of kinetic friction mu k and coefficient of static friction mu s. The spring is in its natural length when a constant force of magnitude P is equal to 5 mu k mg by 4 starts acting on the block. The spring force F is a function of extension x as F equal to kx cube, where k is a spring constant. Assume the force P is sufficient to make the block move. The maximum extension in the spring is so this was a diagram. So there is a block and it's a rough surface. Mu k value is this, and it's having a mu s value, that is a coefficient of static friction, and we have a spring which is having a spring constant as a k. So if you move the block from here to somewhere like up to here, so this spring will expand. So this spring will expand like this. The spring will expand and will have some spring force which will act in a downward direction. So which will act in a this back direction or opposite direction to this applied force, right? And there is a friction also which will act here when this block is moving in a forward direction. The friction will also act in a backward direction. So initially this spring is initially the block is at rest, and when it was elongated to, or spring is elongated to maximum value, again the block will be at rest. Therefore, according to this work energy theorem, the work done by all these forces like a spring force, applied force, as well as a frictional force must be equal to 0, because initial velocity as well as the final velocity of the block is 0, right? So let's solve the problem. Let me have a logic number 1, right? Allow logic number 1 is I have to find all the forces which are acting on them. There are one is applied force. This applied force is already provided, which is nothing but 5 mu k mg by 4, right? And there is a frictional force, that is lava fk, that will be equal to, since the block is moving in a forward direction, mu k into lava m into g. And there is a spring force, which is fs, will be equal to, this is given in the question, that is the spring force is equal to kx cube. The spring force kx cube. So these are the forces which are acting on the block. All the work done by these forces should be equal to 0 according to this work energy theorem. So we have work done by all the forces will be equal to, this work done by all external forces will be equal to what? Will be, or work done by all the forces external as well as internal will be equal to change in kinetic energy, which is nothing but 0. Therefore the work done by all, which can be written as integral of this one is nothing but 5 lava mu k mg by 4, right? So here it is, this kinetic friction is acting in a opposite direction. Therefore I can write as a minus mu k into mg. The spring force is also acting in a opposite direction, minus I can write as a k x cube, right, into dx is equal to 0, right? And we have to integrate from 0 to x. Therefore if I just integrate it, I'll have 5 mu k mg by 4 into x minus mu k mg into x minus k x power 4 by 4 will be equal to 0. Therefore I can write 5 mu k mg by 4 x minus mu k mg x, right, will be equal to k x power 4 by 4. This x and x all get cancelled. I can write as, if I do this LCM and all, I will get here, how much I'll get? Mu k mg by 4 will be equal to k x cube by 4, right? So this 4 again get cancelled out, therefore I can write this x cube equal to mu k m g by k, right? Therefore x equal to mu k mg by k whole power 1 by 3, right? So that is a maximum extension in the spring. Thank you.